Hi, this is David Voss, CCIE 11372, and in this video you're going to learn about IPv6 routing. Specifically, we're going to focus in on RIP, OSPF, and EIGRP changes to support IPv6, with the understanding that ISIS and BGP underwent the least amount of modifications to support IPv6 because they were built with extensibility in mind. Cisco routers do not route IPv6 by default, and this capability should be activated with the IPv6 unicast routing command. Cisco routers are dual stack capable by default, meaning they are capable of running IPv4 and v6 simultaneously on the same interface. IPv6 allows the use of static routing, and it supports specific dynamic routing protocols that are variations of the IPv4 routing protocols modified or redesigned to support IPv6, such as RIP Next Generation, OSPF version 3, and EIGRP version 6. We will talk about each of these routing protocols individually. Before we do that, let's talk about what they have in common. RIP-NG, OSPF version 3, and EIGRP version 6 are new routing protocols that work independently of the IPv4 versions, and they run in a completely separate process on the device. BGP and ISIS are exceptions to this rule as they route IPv6 traffic using the same process used for IPv4 traffic, but they use the concept of address families that hold the entire IPv6 configuration. Many of the issues with IPv4 still exist with IPv6 routing, such as name resolution and non-broadcast multi-access environments. An important aspect is that IPv6 routing protocols communicate with the remote link local addresses when establishing their adjacencies and exchanging routing information. In the routing table on an IPv6 router, the next hops are link local addresses of the neighbors. As mentioned, static routing is one of the options that can be used in IPv6, and it has the same implications as in IPv4. A route can point to the next hop, a multi-point interface, or a point-to-point interface. To support IP version 6, all of the IPv4 routing protocols had to go through adaptations. Each had to be changed to support longer addresses and prefixes, and the actual messages used to send and receive routing information have changed in some cases as well, using IPv6 headers instead of v4 headers. But in particular, like their IPv4 versions, each version 6 IGP uses v6 multicast addresses. Those are just a few of the changes, but even with those changes, each IP version 6 IGP has many more similarities than differences compared to their respective version 4 cousins. Let's start with RIP. The overall operation of RIP Next Generation closely matches that of RIP version 2. Routers still send periodic full updates with all routes. No neighbor relationships occur. The continuing periodic updates also serve the purpose of confirming that the neighboring router still works. The big difference between RIP version 2 and RIP Next Generation configuration is that RIP Next Generation discards the age-old RIP network command and replaces it with an enable interface subcommand. Finally, RIP Next Generation allows multiple RIP Next Generation processes on a single router. So an iOS requires that each RIP Next Generation process is given a text name that identifies each RIP Next Generation process for that one router. Next, let's talk about EIGRP. Cisco originally created EIGRP to advertise routes for IP version 4, IPX, and AppleTalk. This original EIGRP architecture easily allowed for yet another layer 3 protocol, IP version 6, to be added.
As a result, Cisco did not have to change EIGRP significantly to support version 6, so there are many similarities that exist between version 4 and version 6 versions of EIGRP. Now regarding OSPF, in order to support IP version 6, an IETF working group took the OSPF version 2 standard and made changes to the protocol to support version 6, resulting in the new protocol named OSPF version 3. To migrate to IPv6, routers run OSPF version 2 for v4 support and version 3 for IPv6 support.
So here's what you've learned. You've learned about the updates required in routing protocols for IPv6 support. And then specifically, we dug a little bit deeper into RIP Next Generation, OSPF version 3, and EIGRP version 6. This is the information you'll need to know for your CCDP architecture exam. Good luck in your studies.